With the rapid evolution of information technology, we need stronger capabilities to handle huge volumes of data. Mass data requires efficient computing and storage. High-performance computing, or HPC, is developed to address this need, and it has become an important driving force behind the technological and social advancement. For example, HPC can greatly shorten the R&D of new drugs by accelerating drug screening and molecular analysis. In the R&D of new cars, HPC uses data to simulate physical collision, greatly reducing R&D costs and duration. For genome sequencing, HPC shortens human genome sequencing from 13 years to just 1 day. And with the help of HPC, the weather forecast accuracy is much higher than it was 10 years ago. Storage is the data infrastructure for HPC, and the evolution of the HPC industry has caused higher storage requirements. First, innovation of traditional services and the rise of emerging services result in the continuous generation of data, requiring storage to deliver higher scalability at a lower TCO. Second, the popularity of homogeneous computing power, such as GPU and HPDA, takes us into an era of diversified computing power, and this brings increasingly complex workloads to storage. Last, combining traditional HPC and big data is the mainstream. The increasing use of high-performance data analytics, or HPDA, requires efficient data mobility. This means data copies must be reduced, with one data copy shared over multiple protocols to improve analytical efficiency. To address these challenges, Huawei releases the next-generation OceanStor Pacific storage for HPDA to unlock data potential with extraordinary storage power. The OceanStor Pacific series innovates in 3 aspects to define the next-generation storage for HPDA. First, OceanStor Pacific is designed for hybrid workloads. A single storage system can handle both large file, bandwidth-intensive workloads and small file, I/O-intensive workloads, eliminating performance silos for faster data processing in all scenarios. Second, our high-density hardware is future-ready and leads the industry in terms of both performance and capacity densities. Last, the OceanStor Pacific adopts an innovative architecture to support multi-protocol interworking for efficient data mobility in HPDA scenarios. Let's take a look at these innovations. We launched the next-generation OceanStor file system called OceanFS, which intelligently distinguishes between large and small I/Os and handles them in different ways. This allows one storage system to support both high bandwidth and high ops applications. Let's take oil and gas exploration as an example. Seismic data processing produces bandwidth-intensive workloads, whereas seismic data interpretation produces I/O-intensive workloads. Conventionally, 2 storage systems are used to handle these workloads separately, resulting in complicated management and maintenance as well as time-consuming data copying. By contrast, OceanStor Pacific effortlessly solves these problems. We also launched Distributed Parallel Client, or DPC, to meet the need for high-access concurrency in scenarios such as weather forecasting, satellite remote sensing, and supercomputing. DPC provides standard POSIX and MPI I/O interfaces for upper layer applications and supports RDMA networking to deliver superb compatibility and performance. HPC is performance and capacity intensive that requires increasingly high capacity and performance densities, which is why we launched 2 high-density storage products for HPC. OceanStor Pacific 9950 is a storage model that features a high performance density. It contains 8 storage nodes in a 5U space, with support for up to 80 unique half-palm NVMe SSDs. It supports 160 GB per second bandwidth and 2 million IOPS, with a performance density 30% higher than the next player in the industry. OceanStor Pacific 9550 is a storage model that features a high capacity density. It houses up to 120 3.5-inch SATA disks in a 5U space, with a density 3 times higher than general-purpose high-density servers in the industry, reducing footprint by more than 60%. A single node provides a raw capacity of 1.68 terabytes. the disk utilization reaches up to 91% with the use of Huawei Elastic EC. In emergent HPDA scenarios, such as autonomous driving and financial anti-fraud, the file, object, and HDFS services may be used in different phases of a pipeline. Traditionally, the three services are provided by three storage devices, meaning data needs to be copied multiple times between devices, impacting efficiency and wasting storage space. In contrast, the Multiprotocol Interworking capability of the OceanStor Pacific enables the same data to be accessed over multiple protocols without data copying, supercharging pipeline efficiency and storage utilization. All services can provide full semantics and premium performance without the need to install any gateway or plugin, which truly sets OceanStor Pacific apart from other products in the industry. That's it for the architecture features of the Huawei next generation storage for HPDA. We also have other videos to tell you more about these key technologies. Thank you for tuning in and see you next time.